Good day, everyone. We are Group 9 from 11th Sem Wisdom. Before we start with our discussion, we prepare some practice exercises. Distinguish whether the following functions are continuous or not. So for the first function, f of x equals 3x squared minus 4x plus 1 over x minus 1, where x equals 1. Here is the graph. The first function is discontinuous. The next, h of x equals x squared over 2x squared plus 17x plus 8, where x equals 8. The second function is continuous. So a function is continuous if you can draw the graph without using your pen or pencil, and the graph has no breaks or holes. So what if the graph wasn't presented on a given function? This is where a function f of x is said to be continuous at x equals k if the following three conditions are satisfied. First, if f of c does exist. Second, if limitation of f of x where x approaches c does exist. And the third, if f of c equals limitation of f of x where x approaches c does matches. So here is an example. F of x equals 3x squared minus 4x plus 1 over x minus 1, where x equals 1. So here is the graph. Now, let us apply the first condition where is f of c. We simply substitute the value of c, which is 1, to the x variables. And then we got 0 over 0, or known as indeterminate. For us to eradicate the indeterminate, we need to apply the second condition, which is the limitation of f of x where x approaches 3. We simply factor the 3x squared minus 4x plus 1, and that's how we got 3x minus 1 times x minus 1. We need to cancel out the same terms, and the only thing that is left is 3 times 1 minus 1, and the answer is 2. So the f of c is indeterminate. So meaning it is discontinuous. For us to get the continuous graph of it, we should make the function a piecewise function. That's how we got 3x squared minus 4x plus 1 over x minus 1, where x must not be equal to 1. Then second, if x equals 1, then the answer is 2. And here's the graph. As you can see, compared to the first graph, the second graph has is thus is continuous right now compared to the first graph, which is discontinuous. Now for the question number one, it said here that g of x and h of x are both polynomial functions. We know that polynomial functions are automatically continuous at any point, and there is no condition that can break it. Next is an f of x is continuous at x equals k. So x equals k is always continuous everywhere because it is constant. So pwede po natin palitan po yung k ng c, and then same lang po yung value nila since constant nga po sila and always continuous on it. Then next, is it correct to conclude that f of x is continuous on interval from a to b such that a is less than k and less than b? Why or why not? It will all the interval from a to b such that a is less than k and less than b is not always continuous because there could be a discontinuity at x equals k. If the function has a jump, hole, or any disruption from at interval from a to b, it violates the condition of continuity. Even though k is within the interval from a to b, the presence of discontinuity at that point breaks the continuity of the function over the interval. So, we might conclude here po that A is the interval from A to B such that A is less than K and less than B is not always continuous po. Since according to it nga po, possible pa na may mga jumps or holes or any disruptions po if concluded po yung K po sa interval from A to B even though it is within the interval. Then next for the question number 2.
For question number 2, is y equals 2 raised to sine x continuous for any real number x is equal to c? Why or why not? The function y is equal to raised to sine x, where x is equal to c, is always continuous. Since it's constant, and no matter what constant nor letter you change on it, the value will always be the same. Just like the graph below, even though the constant was different but the graph structure were the same. For example, we evaluate the c to x approaches to 1. When you graph it, it will be the same since the value of x and c were the same.
So for the question 3, we have piecewise function here. We need to find the value of a. However, there's a condition which it must be less than or equal to x and greater than x. For us to get the value of x, let's substitute a to x variables. Next, let's transpose negative 12. That's how we got positive 12. Then factor it. Lastly, transpose it. And that's how we got a is equal to 3 and a is equal to 4. As regards to the condition, we chose positive 3 as the value of a. And now, let's graph it.
To find the value of k that makes the function f of c is equal to 2x plus 7 over x plus k continuous on the interval from 5 to 8. First, find the derivative of the given function using the quotient rule. Derivatives of c is equals to 2x plus 7 over x plus 7 squared minus 1 over x plus k. Evaluate the derivative at the endpoints of the interval from 5 to 8. Derivatives of 5 is equals to 2 times 5 plus 7 over 5 plus k squared minus 1 over 5 plus k. Derivatives of 8 is equals to 2 times 8 plus 7 over 8 plus k squared minus 1 over 8 plus k. Since the function is continuous on the interval, the derivative must be equal at both endpoints. Set derivatives of 5 equal to derivatives of 8 and solve for k. 2 times 5 plus 7 over 5 plus k squared minus 1 over 5 plus k is equals to 2 times 8 plus 7 over 8 plus k squared minus 1 over 8 plus k. And last, simplify and solve the equation for k. The value of k that makes the function continuous on the interval from 5 to 8 is 1.
Now, question number 5. At what positive integral values of x is the function of g of x equal square root of 6x squared minus x minus 2 at discontinuous? So, going back, I'm sorry. So, as you can see here, you are assigned to find what positive integral values of x had to be discontinuous. Well, shall we keep moving on? Okay, let's go. Here we are. Solving time. I want you guys to look under the square root, the expression under the square root. I apologize for this because that's supposed to be 6. Okay, I apologize, I mistyped it. Anyway, we can say that this expression is a quadratic function, and we need to make an inequality, or it must be greater than 0, or it could be less than 0, because if it's equal to 0, that is undefined. So shall we get started? Over here we have 6x squared minus x minus 2 is greater than 0. Now that we have found out that this is a quadratic function, we can now factor out this equation, and after that we can evaluate this expression. So first things first, we need to factor this out. There we go. We have 2x plus 1, 3x minus 2. So we have two possible equations to solve for the x. Now we have to factor out the expression, or the quadratic. We can now go to solve for the x for both equation. Apologies. Now we have this. Okay, this. So all we need to do is solve for the x. First things first, we need to transpose the positive 1 to the right side. So what is the opposite of the positive? That is negative. Yes, very good. And we have 2x equals negative 1. How to get rid of the numerical coefficient of the x? We need to divide both sides by the numerical coefficient of the x, which is 2. So we got negative 1 over 2. Why negative? Because we have negative 1. Now, the next part, the same procedure. Transpose this to the right side, which will be positive 2, and then get rid of the numerical coefficient of the x. And then when we divide both sides by 3, we have 2/3. Now, after solving, we have now 3 intervals, and those are negative infinity, negative 1/2, negative 1/2, and 2/3, 2/3, and positive infinity. Shall we try to solve this to prove that this is not equal to 0? Now, on the top here, this is the interval of negative infinity and negative 1/2. So after solving it, or evaluating it, 0 times 2 is 0, plus 1 is 1, 0 times 3 is 0, and the only thing we got here is negative 2. So 1 times negative 2 is negative 2, which means negative 2 is less than 0. So that is true. Next, 1 times 2 plus 1 is 3. 1 times 3 minus 2 is 1. So 3 times 1 is positive 3, which is 3 is greater than 0. Alright? Next. Oh, by the way, this is a negative 1/2 and positive 2/3. What about over here? This is a positive 2/3 and positive infinity. So 2 times 2 plus 1 is 5. 2 times 3 minus 2 is 4. Because 2 times 3 is 6, minus 2 is 4. So 5 times 4, it's 20. Yes. Greater than 0, of course. Now, we all know that all of this and this are true. So in conclusion, we can say, the final answer, that now that we can say that this function is defined at all values except at negative 1/2 and 2/3, thus making the function discontinuous at x equals 1/2, negative 1/2, and x equals to 2/3. Apologies for this. It's supposed to be 2/3, and this is supposed to be a 6.